Hello everybody. Sorry for the delay. I learned that different adapters have different qualities and transport the image to that machine here, or they don't. So we know that. We'll be talking about surviving with Git today. So about all the ways to shoot yourself in the foot and to undo that, of course. This is actually a 1-hour workshop, so I could either talk really, really fast or I'll skip a couple of cases, and I think the latter is the better approach. So we'll concentrate on a couple of different cases. I feel I have to say why I'm talking about this specific topic. So one reason is obvious. I am part of the team behind Tower, which is a Git client for Mac and Windows. We've been on the market for 8-9 years and have helped around 100,000 people all over the world, well, work more easily with Git, let's say like that. So take the headache out of Git. And the other reason why this specific topic, undoing things with Git, is that at least I feel sometimes like the man in the middle here in a complex software project. There's a lot to do wrong, and there's a lot to go wrong. And Git is actually your safety net, right? That's why we're using Git. And my job today is to help you understand what options, what possibilities you have to use that safety net. So all of the things you can use to undo the dirty stuff that happens in a developer's day. All right. As I said, we'll skip a couple of cases. So the first 4 cases would have been about discarding local uncommitted changes. So things that we haven't committed yet. We'll skip that. That's easy stuff. And we'll dive right into manipulating Git history, actually. So we'll have, I think, 12 or 13 cases where we talk about how to manipulate Git history. The typing is on me. You can relax. And it gets a little bit more complex towards the end. So depending on your own level of knowledge in Git, you might want to sleep in on the first half and then wake up for the second one, or other way around. No snoring, then you're fine. Good. Easy thing to start with, fixing the very last commit in Git. So this is quite a common case and a true classic, because we might either make a typo in a commit message or forget to add a change that should have been part of that commit. That's very popular. Both things happen really, really quickly. And that's pretty easy to correct in Git. So let's look at that and see what we have. So the scenario is this one, and this really looks bad. So we should correct this commit message urgently. And as I said, as long as it's the last commit, it's pretty easy. So on the command line, this is just a normal git commit amend. -- amend allows you to manipulate the very last commit to fix that. And I can now provide a better commit message. Typos are indeed very embarrassing. Embarrassing if you mistype embarrassing? No, looks good. All right, so let's see what we changed. And you might have seen it flicker, and we now have a correct commit message for that very last commit. The other thing that I said you can do with amend is add another change to that very last commit. So at the moment, we don't have index.html amongst the changes here, so currently not part of the change set here. And if we want to add that to the very last commit, we can do that using amend too. So on the command line, it's a git add to stage that, to add that to the staging area, and then just the same command using amend git commit -- amend and add that to the very last commit. Voila, index.html is now also part of that change set. So we have quite a few possibilities to amend, to fix, to correct the very, very last commit. Now, first case, and the first time you see those yellow warning messages, I'm sorry, that's reality, so there's something to look out for in these cases. Amend is one of those commands where we rewrite history. We manipulate Git history. And there is one big rule to live by to preserve your friendships and to not get killed in your team, and that is, don't manipulate commit history that you have already shared with your colleagues, that you have pushed on a remote that is shared with your colleagues. Use the tools that we're going to talk about today a lot for cleaning up your local history, let's say like that. So you have a feature branch, have worked on that for a couple of days or weeks, and before you integrate that back into a team branch, you can clean up with the tools I'm showing you. Don't do it to things you've shared already. That's the one rule. And then you can step on the gas. All right, so first case, git commit -- amend to change or fix the very last commit. Number 6. So here, the good news is not everything is bad, right? Only C2 is the bad guy in this example. Everything that came before or after is fine, so we don't want to erase everything. We just want to undo this one here. And as a very simple example, let's say we changed about this project into about, and the way revert, that's the tool we're going to use, the way revert works is it creates new data, a new commit that introduces the opposite effects to undo that commit. So revert is quite a non-destructive way to correct a mistake, right? Because we don't go and rip out C2 and throw it away, but instead there's going to be a new commit that corrects the effects of that old commit. Very non-destructive, very easy to use. All right, so let's do that. And let's look at the problem. So let's say we want to revert this one here, right? Change headlines for about imprint was a problem. And at the moment we have this change here. So we changed about into about this project. Let's see what happens when we use revert on that guy. And to do that, I have to remember the commit hash. So I'll copy that. And on the command line, it's just a simple git revert and the commit hash of the revision I want to undo. I now get a window where I can provide a commit message. Why? Because I am going to create a new commit that corrects that old stuff, right? So don't get distracted about that. I'll stay with the standard message that Git proposes because it's quite sensible. It says revert this and that commit with this and that commit hash. So just save and close. And voila, there is a new commit as promised, automatically created by Git with the opposite changes here. So Git is clever enough to figure out, okay, he or she did that wrong, so I'll just turn that around and everything's fine again. Git revert. Number 7. Here the case is a little bit worse, let's say. So everything that came after C2 is actually bad. We had a couple of bad commits, so let's return to that point in time and forget everything that came afterwards, right? So we want to go back to C2 and air quote delete everything that came afterwards. And this is a case for reset. Nope, not this reset, this one. All right, so let's look at the scenario and say we want to return to this one here, right? So this is the state we want to have back, and we want to forget everything that came afterwards. We want to undo everything that came afterwards. Again, let's remember the commit hash of that revision. And on the command line, it's git reset -- hard and the commit hash. If I do that, voila, you saw it flicker, so the newer commits just disappeared and I'm back on that old revision. So you saw -- hard. That means there must be something else, right? So there is -- hard, there is -- mixed, there is soft, and there is keep. I can never remember what soft and keep are, so let's forget those. We can live with hard and with mixed. Mixed is the default, so you wouldn't have to specify that, but I prefer to do that. What does mixed do? Let's try that out. So in this case here, we are going to go back to that revision here, but using mixed this time. And mixed preserves the contents of the commits you are going to undo. So we're about to lose 2 commits, right? These 2 here. But these have change sets, right? Here and here. And using mixed, I keep those changes as local changes. You'll see what I mean. So let's do that. Reset. In Tower, we call this keep changes. On the command line, it will be -- mixed. Same thing. And voila, first half is the same. We return to that revision, but we kept the changes in those commits as local changes. And that can come in handy if you want to make some more changes. You can hop into the editor, or you can say, well, I don't need that, so let's discard that and get rid of it and commit a new. You're quite flexible with that approach, right? Git reset --hard and --mixed. Number 8. So far we've worked on the whole project. But what if you want to turn back time just on a specific file, not for the whole project, but you know that index.html was good at some point, and you want to get that revision back, but only for that file. And you can do that too in Git. So let's have a look. All right, so let's have a look at the file history of just that index.html file here. And I can now see only the history of that specific file. So I know in the course of the project it changed 3 times. There were 3 revisions of that file. And let's say we want to return to that revision here for that file, for index.html, not for the whole project, just for that file. Again, remembering the commit hash. And then on the command line, it's git checkout, then the revision hash, double dashes, I'll explain that in a second, and the file we want to apply that to. Let's execute that and then explain why the hell double dashes. Let's see. All right. We now have changes applied as local changes that bring back that old revision or that version of that file for us in the working copy. Why double dashes? Well, git checkout is quite, let's say, a versatile commit in a command in Git. You could also call it bad naming choice on Git's part, but that's the way it is. So you use it to undo local changes, you use it to return to specific revisions for files, and of course, you use it all the time to switch branches, right? That's the main use of git checkout. So the double dashes are here to make clear we're not talking about a branch. To make that command unambiguous, no misunderstanding, we're not talking about a branch, we're talking about a file. That's the reason. Git checkout, the revision hash, double dashes, and a file name. For the next 2 cases, we're going to use a special Git tool called the reflog. The reflog, you can think of it as Git's diary, I would say. So Git protocols and journals every movement of the head pointer in that reflog diary. So what's a movement of the head pointer? That's a commit, a merge, a cherry pick, a reset. So actually all of the more interesting stuff is protocoled there. And of course that makes it ideal for cases when you've shot yourself in the foot. Everything is documented here. And what can you do with reflog? For example, this here. You might remember case number 7, I think, where we used reset. So you know steps 1 and step 2. And you might notice that it was a bad idea. That's step 3. And you might see the panic emojicon if you notice, wow, I just lost commits, right? And that's a good use case for reflog. And let's see if we can bring that back. But first, let's destroy something. Well, I would say, again, let's return to this revision here and undo and air quote delete everything that came afterwards. So we are about to lose these 2 commits in a second. So let's do that. Let's use reset. We don't need the changes. And voila. That is when slowly number 3 kicks in and you realize, oh, damn, I should have kept those commits. I need those back. panic emojicon, and let's see if we can get those back. On the command line, it's a simple git reflog to open that journal. And this is the journal that I was talking about. So entries are ordered chronologically, so the most recent items are at the top. And if you look closely, you see that the topmost item says reset. Well, okay, we know the journal works because we just did a reset 20 seconds ago, okay? If we want to undo that, let's just return to the state before. And the state before is this revision hash. So I'll copy that. And you could totally use git reset to go back to that revision. No problem, you could do that. I prefer to use or to create a new branch. Let's call that happy ending because everything works. And voila, so we have a branch and we have those seemingly lost commits back. Git reflog and creating a new branch. There's another case that is perfect for a reflog, and that is when you inadvertently deleted a branch. So, case here, maybe you've worked hard on a feature branch and your team lead calls you and says, we don't need that, customer doesn't want it, you can safely delete it. And well, as it happens, he calls again 5 minutes later and says, well, you know what, funny story, we need that back. Number 3, number 4, panic emojicon. Let's see what we can do. All right, so let's look at the scenario. And yeah, so we have this beautiful feature branch here, feature login. And we indeed have a commit that is only present here. So if I am going to delete that, we are going to delete data. We are losing data. Serious. Okay, let's do that. But first, before I can delete that branch, I need to step away from it. That's the current head branch. I can't delete the head branch, right? So I need to check out master. Now I can indeed right-click and delete. I need to force delete because I'm destroying data. And voila! Catastrophe. Let's look at git reflog. All right, so it seems today's our lucky day because before we deleted that branch, we had to step away from it, right? We had to check out master. That was a head pointer movement, and we protocoled that here. I can again return to the state before. Let's copy that. And in this case, of course, it makes sense to create a new branch or to recreate actually that lost branch, feature login, I think it was called, and that commit hash. And let's see what that leaves us with. Okay, branch is back, including the lost commit. Git reflog. Ah, yes. Yes. You might have known that my slides always contain a couple of emojis up there, right? So I brought a poster as a present, but in return I would like to see some emojis here in the audience, right? So whoever impersonates one of the next emojis, 5 or 6 cases, so don't keep it in, let it all out, right? Wins a poster. I want to have some fun too, right? For example, number 11. Okay, keeping it slow, no problem. Moving a commit to a new branch. So in most teams or in many teams, there's a convention that says don't commit directly on the master branch. Don't know how it is in your teams, but that's pretty common. And still we do because we forget. And our job is to clean up because in that case, let's say in number 11, we should have created a separate new feature branch. That's a classic. You should have created a new feature branch and still committed on the old branch. So let's do that. Let's create that feature branch and move that commit over. Number 11. All right, let's see what we have. So, master is currently checked out, and the very latest commit on master reads start new login feature. That smells, right? That smells like it should have been a new feature branch on its own. All right, so the good thing is that master has the correct state. That should have been the state for our feature branch. So let's just take that as a base for a new branch. And let's call that feature login. All right, so that looks good. We now have feature login with the correct state. Now the only thing to do is clean up master so nobody ever finds out, right? So go back to master and use reset to undo that commit on the branch. Just a normal reset, git reset -- hard, and voila, master is clean, your reputation is flawless, and feature login contains that feature commit. On the command line, just create that branch using the branch command and then use reset to clean up. Head ~1 means one behind the head. Yes, please.
Is there a way to do this when your master branch is locked? So you cannot directly commit to your master branch?
I think then you wouldn't have that problem, right?
Oh, that's exactly it. That's really
Yeah. Yeah.
It's been a long day.
No problem, no problem. Keep asking. I don't judge. No problem. You're welcome. So number 12 is a new emoji. Oh yeah.
Should have seen my face like 2 seconds.
The young woman in yellow, please. A similar case, but different in that the feature branch already existed, right? So we don't have to create that, but the problem still is the same. We committed to the wrong branch, and we need to clean that up. Actually, this case looks easier, but it's a little bit more work to do. So the branch is already there, but let's do that. And again, let's look at the mess. So, all right, master is checked out, and the latest commit says newsletter sign-up page, while we are having a feature newsletter branch. Probably not. Probably the wrong branch. So, the way to correct that is to cherry pick that one over. Right, so let's move to that feature branch, and then use cherry pick to integrate just that commit to the correct branch. All right, so here it is. Wonderful. That's the way it should have looked in the first place. And the second step is the same one. Go back to master and clean up using reset. Master is clean, and feature newsletter now contains the commits that it should have contained in the first place. On the command line, a little bit more work. Switch to the feature branch, then cherry pick that commit over, go back to master, and clean up the mess there. All right, so for the last 5 cases or something like that, we're going to use interactive rebase. By some called the Swiss Army knife of Git tools, which I find quite fitting, actually, because a Swiss Army knife has lots of tools, so very versatile, but it's still a knife, so you can cut yourself a little bit. But if you stick to that golden rule from the beginning to not manipulate history that is shared with your colleagues, everything will be fine, and you're only cutting yourself. That's okay. That heals. So what can you do with interactive rebase? For example, edit an old commit message. And you might say, whoa, wait a minute, we did that in case number 5. That's true. But we edited the very last commits message. That's easy, git commit amend. But as soon as you go back further in history, this one here is git commit amend, but as soon as you go further back in history, you can't use amend, and you have to use interactive rebase for that. And actually, that is quite a simple case, so it's a good case to explain how interactive rebase works in general. So we always have around 3 steps with interactive rebase, no matter what we do. So the first one is asking yourselves, how far back do I need to go in history to manipulate that part of history? So how far back do I need to go? We'll see that in practice in a second. The second step is to actually start the interactive rebase session with that command. And the third one is you're going to get an editor window with that part of history that you selected. We'll see that. And the important thing here is to not make the changes in that step already. You'll see what I mean in a second. That's something to remember. Let's do this in practice. And that was case 13. All right, so let's change the commit message of that revision here. So it's an interactive rebase. First step, how far back do I need to go back in history to manipulate that part of history? Always at least the parent commit. So at least here I need to go back. I can remember the commit hash here, that's one possibility, or I can just count. I'll prefer to do a little counting dance, so head, -1, 2, 3. All right, so git rebase dash interactive, head, that's a tilde. I say minus, don't get distracted, that's a tilde, 3. All right, and that's the promised editor window. And to make that clear once more, we do not go ahead and do that. Just to make that clear, this window is just to mark up what you want to do. So I just marked up line number 1 that I'm going to reword, which is gitish for changing the commit message. All the action keywords are documented here, so nothing to remember. The other thing to remember in this window is the order of the commits is reversed, right? So improve headline for imprint, that third one here, is actually the newest one. From Git's perspective, this one is correct because it goes and reapplies every commit in turn. Just don't get confused. Order is reversed, nothing broken. So that's actually all I have to do in that step. Mark up what I want to do. I mark that reword, save and close. And now I finally get my chance to actually do what I want to do to change the commit message. That's the old commit message opened up for editing again. Let's do a very important change, the markup structure. Save and close. And voila, here we go. We just manipulated history. Git history, but history. What else can you do with interactive rebase? Glad you asked. Delete commits, for example. So we can really go ahead and rip out commits and delete them. Let's do that. And let's find something to delete. Let's throw out this one here. So, interactive rebase, step 1, how far back do I need to go in history? Parent commit. So either copy that commit hash or remember that, or head -1 -2. Git rebase dash interactive head tilde 2. And again, I'm left with that editor window. And you remember that grand rule I just introduced to not make changes in that window? Well, there is an exception, and that's this. Whatever line doesn't make it when I save and close is deleted. So that's an alternative way to delete commits. But I'm a gentleman, so I will write drop. We're not savages, right? That's the official action keyword, drop. By marking that line with drop, I'll tell Git I want to delete that. Save and close. And voila. It flickered and that one is gone. Number 15, that's when the EmojiCon contest gets really, really hard. I think I have another poster. Does anybody want to try the cow? Oh, damn. Now, there's 2 more cases. So you can also squash commits using interactive rebase. And squashing means combining multiple commits into one. So there's this general rule to rather keep commits smaller than bigger. So you won't use that too often, but you can indeed squash and combine multiple commits into one. And let's do that. And let's say, let's combine these 2 beauties here. It's an interactive rebase, so first step is doing the counting dance. We need to go back to the parent commit, so head -1, 2, 3, this one. Git rebase dash interactive head tilde 3. And we're going to use a new action keyword, of course, and that is squash. Now, the one thing you have to know about squash is that it combines the line you mark up. So I marked up line number 2 with the one above, with the one before. So by marking up line number 2, I tell Git, please combine number 2 with the one before. I want to melt together these 2 lines, right? That's all I do in this step. I'll save and close. And another editor window pops up because I am about to create a new commit, that melting commit, right? That combining commit. So I have the chance to provide a commit message for that one. Combine 2 into 1. I'm well known for providing excellent commit messages. And voila, we just combined 2 commits into 1. Right? So we combined the change set, and you saw that I left the old commit messages in there too. I am contractually obliged to show you how easy that is in Tower. I'm very sorry. So you can just drag and drop it here, and that's a squash. So, yeah. Well, number 16. Ah, there he is. Wonderful.
Thank you.
I'm out of posters, so chill. That's actually my favorite here. That is fix-up. It's my favorite because it's very, very real life, very, very practical, because number 1 is we made a mistake, right? Doesn't matter what it is. We forgot to add something. We should have deleted something. There's a wrong line in the code. Doesn't matter. Any mistake. And the natural instinct is to just make a new commit that corrects the problem in the old commit, right? That's okay, but not very beautiful, because we have original commit and let's call that a band-aid commit. So original commit, band-aid commit. And if you do that for a couple of weeks, original band-aid, nobody will be able to read that commit history, right? It's dirty as hell. Okay. So the thing that fix-up does is it takes that band-aid commit that has no semantic meaning, right? Applies its changes to the original one and throws it away. So you have what you wanted to have in the first place. Fix up. So let's fix something. All right, so let's pretend that this one here is incorrect or incomplete, and we already prepared the changes that make it complete, right? So these changes here in error HTML make this one here complete. Currently doesn't contain error HTML. Right. So first step is to actually just commit those changes. So that's the normal staging, and git commit, but of course not a simple commit, but a fix-up commit. And here I'm going to tell what commit I want to fix up with that commit. Right? So this is the one I want to correct, right? This here. So let's copy the commit hash here and tell git with that new commit and that little change here, I want to fix that commit, right? You probably expect fireworks to happen now. I'm sorry, not going to happen. We just have a new commit, that Band-Aid commit, with those changes. But you see there is something going on. Fix up, exclamation mark. What? Something is about to happen. It's still an interactive rebase, so let's do the little counting dance. We want to fix this one, so let's go at least to the parent one. Head minus 1, 2, 3, 4 this time. Git rebase interactive head tilde 4, and second part of the secret sauce, auto squash. So this is a two-part solution actually. The first part is to mark up that Band-Aid commit using fixup. That's the first part. And the second part is to use auto squash when you initiate that interactive rebase. 2 steps. And the good news is that's it. In this window, I do not have to do anything because Git did 2 things for me. First, it automatically marked that commit as a fixup. I didn't do that, right? So line number 2 is marked as fixup. And it did another thing for me. It rearranged, it reordered the commits. So that fixup was actually the newest commit, right? So it should have been at the bottom. But fixup is a special form of squash. And you remember that squash rule. Squash combines with the line before. In order for that to work, Git automatically rearranged that for us. So it put it in line number 2, and it combines with line number 1, the one we want to fix. To make a long sentence short, we don't have to worry in that dialogue. I do not do anything, I just save and close. And voila. 2 things happened. The changes of that Band-Aid commit were applied in that original commit, and it's been thrown away because it has no semantic meaning. We don't want to have that in the commit history, and your colleagues are still impressed because you make no mistakes. Crazy. Again, let's just mention how to do that in Tower. You can just hold down Option key, and that's a fix-up. Just saying. All right, last case. 2-part solution, fix up when you commit, and auto squash when you initiate the interactive rebase. Last one. And this is actually just to brag a little bit about what interactive rebase can do. Short answer, anything actually. And in this case here, we are going to split or to edit an old commit, which means we are going to open it up again for editing. So we can hop into the editor and make more changes, undo a couple of changes, add files, delete files, and then decide to commit those changes as one new commit and the other changes as a second new commit. So we are totally flexible. We're opening up an old commit for editing. Now, here's the problem. You know I'm a bad typer and I refuse to do that on command line, so I'll show you how to do it in Tower, and you know it is possible. I'll leave it for you to figure out. All right, so let's split something. We need a couple of changes. Let's take this one. All right, so right-click and edit. And we're now in the middle of an interactive rebase session here, so that old commit is broken up again, and we have the change set as local changes in our working copy. You can hop into your editor and make more changes and say, well, this doesn't make sense, this second paragraph here, this second chunk, so let's discard that. And then, well, semantically, it would have made sense to commit these 2 changes as one commit. Commit number 1. And the other changes as a separate commit, commit number 2, and continue marks that interactive rebase session as finished. And let's see what we have. Ah, wonderful. We just split up that old commit into multiple new ones. Very, very flexible. All right, I've said it a bazillion times. Let's say it one more time. Do not rewrite commit history that has been shared with your colleagues because you will make no friends. And that is, of course, the case when you use git commit amend. Anytime you use interactive rebase, anytime. Sometimes when you use rebase or reset, so be a little bit careful with those. I presume that those 12 cases are now burned into your brains, but maybe you have a gap at case 11, let's say. This is a good slide to photograph because actually we have made those cases and the ones I have left out because I had no time as little videos. So 2 to 3 minute videos, and you can catch up on number 7 or number 1 to 14. Don't know. All right. I'm a good guest because I brought gifts. I know that not everyone had the talent to participate in that, emojicon thing. So I brought the same poster shrinked. It's crazy. You can shrink it as many times as you want. We're experimenting with that size. So it is a postcard, so you can send it to someone, which is actually quite cool because they only receive invoices per mail. So you can try that. Or you can be selfish and put it on your desk because it contains quite some practical advice. Right? Drink good coffee. It's always good to remember. Or stay dry. Be pragmatic. And on the back, if you want to try Tower, you can do that. There is a coupon code on the back if you want to try Tower. Make your life a little bit easier with Git. And again, the URL to that video series. Enough postcards? That's it from my side. I am done energetically and from my knowledge too. That is, by the way, a real email address. So if you have questions, shoot me an email. Yeah, you have to say that, I think, in talks. If I know the answer, I will respond. If I don't know the answer, I will respond too and tell you I don't know the answer. And there's stickers here if somebody stickers. Thank you very much for your time. Have fun.